Okay, solving a matrix using the inverse method. This is an interesting one. So we want to find x, y, and z using inverse. So we have three equations: 1x, 2y minus z equal 4. Okay, so we form a matrix. So we 1x, 2y minus 1z. Alright, and here I just change it to say x1, x2, and x3, which is the same as saying x, y, and z. So ax is equal to b. A by x will be equal to b. And let's continue. So we basically just rewriting the equations in matrix form. That's all. Firstly, we find the determinant of A. Okay, the determinant of A will be, because of the first column, we have 1, which will be plus. So it's plus, minus, plus. And we block off the row as well. So we get minus 1 by minus 2 minus 3 by 3. Alright, for the second, take out 2, column and the row. 2 will be negative, so it will be negative 2. Alright, 2 by negative 2 minus 3 by 4. And the next one will be minus 1, so minus by a plus, give us a minus. So 2 by 3 minus minus 1 by 4. Alright, and you get 2 minus 9, which will be minus 7. Minus 4 minus 12 by minus 2 is plus 32. And 6 minus minus 4 by minus 1 will be minus 10. And when we add it up, we get 15. And we know this correct because we did it in the last video as well. So the next thing now is to find the cofactor matrix. Alright, to find that, we'll basically have to take the original matrix and do what we did for the determinant, but for all the numbers, all the elements in the matrix. So remember that it's plus, minus, plus, minus, plus, minus, etc. But you don't use the number in front anymore. Okay, so when we block off 1, right, you'll notice here that it's just plus. So that just keep that in mind. So we could take this here, negative 1 by negative 2 minus 3 by 3. We could bring it across. We already did these, we could bring them across. But what we have to take caution with is the sign, because the sign could change, because this minus 1 here is end up over here. But we really want, but if you look in the cofactor side, you'll notice that it's plus. So just imagine to have a plus 1 or a negative 1 in front of each one of these here. So it'll just come down to negative 1 by negative 2 minus 3 by 3, leaving out the number in front. And we'll get, well, it have a positive here, so you get negative 7. And if you do for the next one, you'll see the difference. So we have 2 by minus 2 minus 3 by 4. And that will give us negative 4 minus negative 12, but we not multiply by negative 2 here. Okay? We actually multiply by just negative 1, which will give us 16. So just don't make the mistake when you already found the determinant and you use the first 3, but when you bring it here, you forget to change the signs. That is why it's good to just write it over when you find the cofactor matrix one time, so you don't mix up the signs. Right? It's really easy because if I bring it across, notice that this plus will be different, which means you'll throw it off. So that's really it. And then you just do it for each one. So let me continue. So we want to find 2, block off 2. We will get, let's block off 2. We will get, right, 2 by negative 2 minus 1 by 3. By 2 minus 1 minus 3, yeah. Right, and then we want to find 1, block off 1. We will get 1 by negative 2, negative 1 by 4. And just continue to do it this way. I recommend you probably, I don't know, maybe erase or something if you're doing it on paper, or just block it off. I use my pen and my finger to block off the row and the column. Just to eliminate any error now, because the thing about matrices is it's pretty easy to understand what to do, but your errors is something that you have to work on cleaning up. So by taking the time and having a process where you're writing things down, even sometimes more than once, it'll help eliminate the errors. Okay. So for 3, block it off. Get 1 by 3 minus 2 by 4. 1 by 3 minus 2 by 4. Alright. And yeah, I didn't bother to write it out in this form because I probably just dial these on my calculator or something. But this is just to keep it a little shorter. And let's do the last one. Last row 4. Alright. So you get 2 by 3 minus 1 by minus 1. You see it here. And 3. You get 1 by 3 minus 1 by 2. And for the 2, you get minus 1 by minus 1 minus 2 by 2. Minus 1 by minus 1. Sorry, 1. I'll do that one. So for the last one, we get 1 by minus 1 minus 2 by 2. 1 by minus 1, 2 by 2. You should be pretty good at building your eyes for it, like blocking it out, and you should get familiar with it now, with the technique of blocking out and writing them. Because like what I was saying before, it's very easy to write down the wrong thing or the wrong sign and get it wrong. Right? And depending on the level you're at doing this course, yeah, the teachers and and the people correcting the exams will expect you not to make mistakes because they know that you're not really doing anything overly like difficult. It's more just the sheer amount of complexity alone is what kind of make you make a mistake now. But anyway, so now we have now we form this matrix here, which is the cofactor matrix. So negative 7, 16, 10, 1, 2, 5, 5, negative 5, negative 5. And we want to transpose this matrix now. So cofactor transpose, which is CT, will be equal to, we have, all we're doing is we're taking this row and we're swinging it down to this side here. Alright, so coming across here as the column. Let me show you. So negative 7, 16, 10, negative 7, 16, 10. And that's what we're doing. So the second row become the second column and the third row become the third column. Simple like that. And that is equal to adjoint A, which is something that is asked you to find in exams and stuff quite frequently. So, okay, so we found adjoint A, and we still have to solve for x, y, and z. So let's say that x1, x2, x3 will be equal to inverse. The inverse will be 1 over the determinant, which we found to be 15, multiplied by adjoint A. So we can leave it in this form for now, and we could say that adjoint A multiplied by B, which have been the answers, will give us, suppose we multiply two matrices by each other. So negative 7 by 4, which would be negative 28, plus 1 by 3, which would be 3, negative 28 plus 3 will be negative 25, and 5 by 5 is 25, so negative 25 plus 25 will be 0. 16 by 4, which would be 64. 2 by 3, which would be 6. Negative 5 by 5, which would be 25. We add it up, you get 45. 10 by 4, which is 40. 5 by 3, which is 15. And negative 5 by 5, which would be negative 25. So 40 plus 15 minus 25 will be 30. And if you're lost in this part here, we just multiply in each row by this column. And that will give us this row here. And then we multiply this row here, second row, by the same column to give us the second row on this side. And the same thing, the third row by the same column. Right? So we get 0, 45, and 30 for x1, x2, and x3. So all we have to do is divide by the inverse now. And say 0 on 15 is 0, 45 on 15 is 3, and 30 on 15 is 2. So x1 is 0, x2 is 3, and x3 is 2. And that is it. We just solve the equation using the inverse method.